So good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and Mend. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting presentation today. First, I have just a couple of housekeeping notes to cover. First, today's session is being recorded. So if you missed any of our discussion, or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we do want you to go ahead and send those over using the Q&A tab, which can be found on the right side of your screen. That's also where you're going to find the chat tab, and that's where we want to encourage you to talk with one another, talk with us, just let us know your thoughts throughout today's program. And finally, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. Our topic today is closing the gap, reducing enterprise AppSec risks without disrupting deadlines. And I'm joined by Jeff Martin, VP of Product at Mend. Jeff, thank you so much for being here with me. I'm going to let you take it from here.
Awesome. Thank you, Cody. All right. So everybody should see my screen now. Somebody let me know we're actually doing that.
We're all good to go, Jeff.
Awesome. Thank you. Oh, somebody's from Toronto. We were just talking about Toronto. All right. So let me get started here. So first, closing the gap, reducing enterprise AppSec risks without disrupting deadlines. So I imagine a lot of you, come on. It helps when I click on the right thing. So I imagine a lot of you are pretty familiar with something that looks like this. There's a recent study last year, Ponemon. I just happened to like it, so I pulled it, saying basically that people do recognize that security is becoming an increasingly important objective within their application development cycle. Just in the last 5 years, that's why I like this particular chart. That's jumped up about 15%. That's a big jump forward. People really do understand the importance. And for a lot of people, that's actually a recent realization. That's driven a lot by what kinds of attacks people are actually experiencing. Application security, hacks to insecure applications, to use Ponymon's phrase here, outpace the growth for attacks at other points of your attack surface, like your network layer or device layer, or even like consumer-facing websites. That's pretty unusual now. Fundamentally, the most insecure part of anybody's actual application is the application layer itself. So this is not just, as I jokingly put in the slide here, a top priority. It's the top priority for security. So here at Mend, we sell application security tools. I'm not talking about that today, but it does mean that I get to talk to a lot of people who are concerned about the security of their application. There's a few things that everybody keeps citing. One is security slowing me down the way I'm doing it right now. And another one is I don't really know what I'm doing, if what I'm doing actually influences the real risk exposure of my application. So I'm going to try to cover both of those points. But, look, just to kind of really level set on the problem here, there's a couple of things that are really driving this insecure application problem. One is, of course, the use of open source. I'm sure everybody's been used to hearing that. Open source means that you're taking things with a huge attack surface and putting them inside your application. Open source, by definition, is used by lots of people, almost always. And that's where your bad actors target, the things that can affect the most people. The other piece is the growth of more cloud-native development methodologies, service-oriented architectures, tons of APIs that are often exposed publicly. So there's a lot of places where these attacks happen. So, I accidentally don't move forward. There we go. Why in the world does the average application security program I talk to people about look a little like this? A huge issue backlog. So, I'll state it this way. People implement some application security tools. They already have an existing backlog of security issues. New issues are always flowing in, and they're fixing some of them, usually at or below the rate of new issues occurring. You end up with roughly flat amounts of remediation and a growing backlog. Hopefully this is resonating with a lot of you, because this is sort of the state of our industry right now. It is very hard to keep up with new vulnerabilities and weaknesses. So where am I actually seeing my risk change in this? Did my remediation efforts, which are roughly flat, reduce my risk? Is it getting worse because there's new issues? Most people don't actually know. They know how many issues they got in their backlog, they know new issues, and they know the remediated issues, but they don't know the risk. And as a result, they try to close this gap. They say, oh, we have this issue backlog. I have new issues outpacing remediated issues. I clearly need to remediate more. Let's slow down development to do that. Let's put more gaps in there. Let's make sure that we, slow things down enough, maybe even slow down our business value delivery to spend more time fixing these issues. But they don't actually know if fixing the issues is reducing their risk. And there's a few reasons for that. So here's my problem statement slide. So generally speaking, our entire application development industry is stuck on detection of risk. And I'll talk about that a little bit deeper in a minute, along with some of these other points, like I got too many issues. I just have a ton of issues. And if I'm not prioritizing them correctly with some real understanding of the actual risk the issues present, then I'm not actually sure how much impact I'm having. So if I slow things down, I know a cost, but what's my benefit? That brings me to the next point, which is a lot of the processes we implement as an industry tend to function as interrupts. And I'll talk about this pretty in depth in a minute, so I don't want to go too far. But we slow things down, we stop things, and we don't focus on the actual real problem. Finally, the remediation effort, just to go back a whole slide, tends to be flat like this because I'm not doing much to automate it. I'm not, unless I'm hiring more people, which is very hard, especially security-oriented people. They're very expensive and a little hard to come by. I'm keeping my remediation of items relatively flat. This, again, I'll dive a little deeper in a minute, but this is a fundamental flaw that needs to be addressed through automation. So jump back over to my slide here. Apologies for jumping around. I like graphics. And then finally, there's not enough focus on actually measuring what actually matters, the risk reduction. What am I actually doing with all these efforts? All right, so let's dive into some of these a little bit more in depth. And by the way, please throw questions in the polls. I love questions. It's so much better to be interactive, more fun. All right, so I'm stuck on detection, or as I don't know. I recently heard somebody say in a call, at least I know I have issues. Although that sounds more like something I might have said to an ex-girlfriend. But yes. Okay, what do I mean by we're stuck on detection? So your typical AppSec maturity model is I need to identify my issues. Usually this revolves around a few different areas. I've highlighted what I consider the big three. Not surprisingly, they're the ones that, as the VP of product at Mend, we're focusing on solving and detecting for you, which is your open source vulnerabilities, because that's the largest portion of your attack surface. Then you have your proprietary code weaknesses, the stuff you write, the 20% of your code down to maybe 10 or 5%, depending on the application, that you actually write from scratch. And then there's this new source of, I'll call them weaknesses right now, but attack surface, if you will, which is this malicious packages. There's been several of these in the news recently, but injection of packages that look safe but are not, changing of open source components, things like that. So great, this is where everybody sort of starts. You have to know which issues you have. And then the average AppSec company starts handling prioritization. And here's a few of the ways that I see most organizations who aren't doing this really well. But this is just like emergent area. Maybe they tackle, honestly, it's the most common prioritization strategy I've seen. Let's just look at open source vulnerabilities, stuff from the CVEs, and let's make sure we address critical and high. I'll go through why that's not sufficient in a moment. It also doesn't narrow things down enough. I've seen other people focus on things like the OWASP top X 1025. Show me the, for proprietary code weaknesses. I think just a couple days ago, they came out with, the top 25 CWEs, most dangerous CWEs. People tend to prioritize that. So again, it's a little bit of a mistake, and I'll go through why. And my personal favorite, which is, hey, the executives, some jerk like the VP of product, just heard about this thing in the news called Log4j, or one of the 800 other ones in the last couple of years. Let's make sure we're not exposed to that, because everybody's paying attention to it. And then kind of the last stage of maturity here is, I call it remediation. I think that's the best word for it, which is, great, I've got issues. I've done some kind of prioritization. What in the world? I got to go fix them. I got to resolve these issues. I have to mitigate them. I have to remediate them. And the general remediation strategies we see are, what do we have time for? Like, I have some time to devote to remediation. Let's focus on that. The other one that I really don't like is, I'm going to focus on just the things that I'm causing the problem on, instead of thinking about it from the application standpoint in the bigger picture. Things just in my repo, for example. And this is probably the worst prioritization remediation strategy, which is, I'm going to fix whatever's easy to fix. As an industry, we're in detection still. Most application security programs are really focused still on detecting the issues, and they're getting to the point of prioritization, which is why you see these relatively immature processes like just high and critical. And very few people are really focused on the remediation phase. So I anticipate that this is the type of thing that'll take a few more years before we kind of shift where we are over to prioritization, and a few more to remediation. But the good AppSec programs are already further down this maturity model. All right, so if that's one of the problems, where we're just focused on just detection, what does that lead to? Well, if you're only focused on detection and not enough on prioritization, you have too many issues, just period. That's why you have that nice issue backlog I don't know which way is up and right, but one of these ways. That's why you have that issue backlog continually growing. You have too many issues. So to reduce that, which is, to be clear, I love these little quotes that I've gotten from customers where somebody actually saw the issues we detected for them and just goes, wow, this is a lot. Well, yes, it is. And we have the usual conversations. They were like, maybe we just handle critical vulnerabilities, etc. I already went through these, don't need to do it again. But that's a bad process, to be blunt. Why? Well, the biggest thing is severity is really only a starting point. Critical and high is a good, first step, honestly. But there are other things that influence the actual risk of a known vulnerability or of your own code weaknesses. So, some really easy examples here of, let's just say, more solid prioritization strategies would be okay, great. The library is vulnerable. It's got 13 critical severity vulnerabilities known publicly. But I'm pulling in a giant library and I'm realistically only using about 20% of the library. That's not a made up number. That's actually what we see. We have a detection method that our customers use to analyze whether or not the vulnerable method in the library attached to the CVE is actually touched. And we find about 80% of all vulnerabilities are not touched in the average code base. So that's a pretty big jump just from knowing whether or not the method itself is actually exposed. Now, there are still ones you should definitely remediate, even if you're not touching that. But generally speaking, you can deprioritize a vulnerability where the method isn't even being touched, or the function. Another great, really solid prioritization strategy is known exploits. The big secret is bad actors are lazy. They like to use exploit kits and things like that. A vulnerability that's present in every exploit kit out there is a bigger risk than a vulnerability that hasn't been weaponized. So the weaponization maturity of a given exploit is a really important piece that affects your prioritization of the issue. This is so important. It's actually in the CVSS standard. It's part of what they call the temporal score. And you can feed in the exploit ability of these things, the known weaponization of vulnerability, and you will come out with a different CVSS score. So if there's no known exploits, it often shaves 1 or 2 points off the actual CVSS score, usually dropping it a whole severity level. Another really big one, a little bit more focused on, let's say, SAST detection and weaknesses, is what are you attesting to? What are you telling your customers you're guaranteeing? A lot of times in contracts now, when I go to buy software, there are pieces in there that say, I will remediate everything, all CWEs detected in our SAST tooling in the CWE top 25. These attestations are becoming more and more common, as are things like inclusion of SBOMs and everything else. As we get more mature as an industry and more standardized, there's certain standards that are becoming common, especially for specific application industries, finance, God forbid, devices, that you are stating. The fact of the matter is, if you're telling your customers one thing, like we're going to solve everything in the top 25, it doesn't matter what the severity is or anything else. You have to go solve that. You want to make sure that what you're attesting to is accurate. So it's another really good piece to put into a prioritization process. And then this one's my favorite, is shared assets. They act as multipliers. Your attack surface isn't just a one vulnerability. If it's in a core service that many applications are using, or inside a container image, say your base image, if you're developing in a more cloud native and more modern way, um, that is a huge thing to go solve, because it's not just affecting one thing, it's actually being multiplied by many, many users. So shared assets, which is very common in application development, um, should be prioritized over assets that are only used in one spot. Okay, great. Turn that into something concrete, Jeff. Sure. Um, Generally speaking, what I see is that most of an issue backlog, if you were following some of these prioritization strategies, not even necessarily all of them, but some of them, about 80% or so in the average application can be deprioritized. So to kind of go back to the um, slide, I won't pull it back up. That issue backlog, realistically, if you're doing a really solid prioritization strategy, you can cut that down, get it closer to the level of what you can remediate. And you're now doing a better job of actually recognizing your risk. But that kind of brings me to the next problem: interrupting development. Um, I love these little quotes. Sorry for giggling at myself here, but this happened literally like 2 days ago, so I threw it in here. A head of engineering, just we were talking about security, and he goes, I really would like my developers should really be developing instead of fixing issues. I'm like, I agree. I'm a product person. I want new features all the time. So just to kind of recap a few pieces of things that I was saying earlier, some common remediation strategies. What do I have time for? I better fix my stuff. And what's easiest to fix for me? And actually, if you notice, all of those were very personal. What do I have time for? What are my items? What is easiest to fix for me? Not focused on the actual risk reduction, which is a business value of the application. The reason for that is people don't like having their work interrupted. So the real better ways of handling remediation in a more modern and more emerging way is silent, invisible fixes. There's a lot of things you can do to lessen this burden and to stop it from being stop it from interrupting. So look, fundamentally, if you sit there and talk to somebody like me, a VP of product, who's focused on getting more customers and building value for my customers so that they're happy and my business is happy and everybody wins. Yes, I care deeply about security, especially as a security tool vendor. But it can be extremely hard, especially for non-security focused companies, when you have to prioritize the time and interrupts of fixing security versus delivering value to my customers where I can see some dollars. Security ends up being thought of as almost insurance or a problem that might happen. Very similar to what quality used to be before we really tried to bring that in earlier. Quality used to be viewed as, and still is to some degree, a triage process. All right, yeah, I know I have issues, but nothing's perfect. We'll fix it later. Security really should never be, let's fix that later. It should be mitigated by design. What do I mean by that? Well, when the application is designed, the fancy terms for this that I try to stay away from the industry terms on, but zero trust. The services, your shared assets, everything else, the more mitigation is built into your actual architecture, the easier and less likely it is that you are going to have to, let's say, mitigate those issues after the fact. You can state, yes, this input isn't happening. However, fundamentally with this item, I have this input coming in, say a SQL injection, but you know what? I'm sanitizing all my inputs. That's mitigated already by design. The best way to mitigate by design is to educate people. Education is the best remediation. Whoa, I think I just collapsed everything. My fault? I don't know what I did. There we go. I gesture wildly. I think I hit the minimize all button. So, look, fundamentally, the best way to remediate an issue is to take that issue, turn it into an education point, and prevent the next time coming in. That is the best possible strategy for reducing the amount of issues that you have. I'll go through some automated ways to do that in a second. But education is really, really, really important. However, one really good strategy for education, bring a friend. I don't know, I phrase this a little tongue in cheek, but code review has been a process in modern application development for a while. And the best forms of code review involve two people. Why? Because it shares knowledge. It also creates a little bit extra pain that makes them want to prevent that from next time. This is more important in security than any other aspect. There are people who know security in your organization. So those people should pair up with the people who don't know the security, especially for things like proprietary code weaknesses, right? Here's why this loop that doesn't exit correctly is a problem. Let me show you how to do it correctly. It's also more fun, to be honest. It's a little less interrupty when it turns into an education session. Developers like to learn as much as they like to develop. Okie doke. So, did I really just say okie doke? That's pretty bad. Education is the ultimate shift left. I hate using all the buzzwords, but this is a good one in this particular case. We talk about shifting left and detecting things early so that their remediation efforts are less. Well, every time you spend any time in education, you are doing it all the way to the left before the code's written. You're making your developers better. But everything I kind of just talked about was really focused on manual remediation. This is my one subsection with a little question mark, because you just don't need a person to fix everything. Code is increasingly meant to be consumed by other code. There's no reason we can't automate most, or especially the high value, remediation items for security the same way that we do things like automated quality tests that you're probably already doing. So again, there's my little remediation slides. Again, very focused on what I can do. But one of the best ways to do some of this is, again, I kept my silent and visible fixes here because I don't know, I just like the phrase, but automation. It's absolutely key for security mitigations and remediations. They really fall out into two big categories of automation for security remediation. Long phrase. First, dependency updates. This is a slightly controversial thing, but is increasingly becoming the standard. Keeping your dependencies up to date for all that open source you're using mitigates and reduces huge chunks of the issue backlog, so you have less to prioritize. There are many dependency update tools I'm a little biased. We have one of the biggest open source free ones, Renovate. But there's lots of ways to do this. Updating dependencies can introduce additional risk if it's done poorly, but not for security, for functional. Because automatically updating, for instance, and creating pull requests to update your dependencies to the latest version the day it comes out is a little on the risky side. What if it breaks? What if it's not very good quality? What if it conflicts with something else in my application? So the best way to do dependency updates is really to think out a dependency update strategy and make some rules. Yes, we'll update to point versions, but not major ones. Or major ones require a quality check. But just keeping things up to date actually means you're getting all the value from any open source updates, of course, but it also means you're getting all of the fixes. There's very few known vulnerabilities that don't have a fix before they're published. Okay, so that's your open source side. Try to keep things up to date, as long as it's not going to break stuff. So what's the other side? Your actual code you're writing. There are now some really great ways to at least make good suggestions on the fixes. The problem with custom code or proprietary code weaknesses detected through SAST is twofold. They tend to have a decent amount of false positives, and I have to go look at the code and figure out how to fix it. This is like a spell check or grammar check that is constantly running, and it gives you these problems. But unlike with a spell check, for example, where I get a nice little red underline, I can right click on it and it says, you should fix this. You spelled transition OIN. Just click here and it applies the fix for you. Most SAST tools don't have that. They have the first half of the spell checker. They detect a bunch of issues for you. They don't suggest the fix. There are a few that do. Again, I'm biased a little bit. Ours does. But fundamentally, these fix suggestions are huge time savers. Think of it exactly like spell check for a minute. If you had, I'll take it to myself. Maybe I won't put it on you. I spell things horribly, especially if I'm going quickly. If I'd have to just get the red underline and couldn't apply a fix quickly, it would take me twice as long to fix everything. I'd have to honestly look up some misspellings and figure out how to spell it correctly. That manual effort is kind of just wasted time when there are tools to be able to give you suggested fixes, especially for the very common things like SQL injections. And then ultimately, and this is where I start talking about measurement, you have to measure the effort spent. So this is where I get all business executive on everyone. If it's not measured, it doesn't count. And if you can't measure it, I don't know what it means. Effort, the interrupts that you're delivering to your security, to your development team because of security, needs to be measured. If you measure it, you will start finding ways to stop the interrupts. It's even better if you measure it and set goals on whatever time period makes sense. Okay, we're introducing this many problems. They're taking this long to solve. We need to cut down the number of problems by 10% this quarter, and we need to cut the time to solve them by another 20%. If you set goals, you will start trying to find the strategies. And these are a couple of really good suggestions because I made them. So, of course, they're really good, or at least I'm not going to disagree with me. But there are others too. There are a lot of ways to do this. Some of it ties right back to what I was talking about with education. Holy crud. Nobody seems to know how to write a safe data sanitization routine. Let's educate on that. wow, we just cut the number of issues a bunch. You need to be able to measure. Boy, it's almost like I thought this out. Measuring this risk reduction. This is something actually a former CEO once told me that just stuck, which is businesses like numbers. I thought it was hilarious at the time. Most security doesn't, and security processes don't actually measure the things that matter. The number of issues that you're fixing has nothing to do directly with your risk reduction. It might indicate, might be indicative of it, but it is not actually proving any risk reduction. What does is the percent of prioritized issues resolved. I don't care how many issues I have. If I can cut half of them or up to 80% of them out, great. Let's cut them out. We can state they don't matter. Fixing them doesn't actually reduce my risk. Why am I spending any time on it? Knowing the prioritized issues you have and then knowing what percent of them you've actually resolved is a lot closer to risk reduction measurement. It's a lot more accurate. But it's not enough to just measure all the efforts and all the issues that you've remediated. There should be a real drive towards education and prevention of issues. And that has to be measured too. Because, especially because, education is moving some of the effort earlier, so you have a curve. Effort now pays off with less issues later, especially around proprietary code and live development. But even around open source, things like making sure when people add an open source library, they're bringing in the most recent version is a huge education piece that can have really meaningful impacts on the number of security issues you have. So this is harder because it's a little more specific to each organization, but there are ways to measure education efforts, the time you spent, estimated number of issues that you're preventing. You can see things like my silly example there of a data sanitization routine. We did education on data sanitization routines, and the number of issues involving data sanitization got reduced by 50% the next quarter. Huge impacts, but take credit for them. And I don't know, this is, I guess this is kind of something I say to my kids a lot. I don't know how it snuck in here. Effort doesn't really matter as much as results. Not in some areas it does, but not in security. Effort is actually my enemy. I want to reduce the effort for the most results. Efficiency. So measure the efficiency. Target, just like you do for most quality organizations, will have a target for automated tests. Target automatic remediation. Set goals. Measure how automated the process has become. Get that remediation line I showed you at the beginning from being flat to going up with the same amount of effort. Secondarily, speed is important enough to measure in security. We don't always do it. It can be a pain to actually measure this, but if you want to reduce the interrupts you're giving to your development team and slowing them down, you have to measure how much you're slowing them down. And again, this can be a little specific on the organization, but in general, this is as simple as here's all the issues I kicked back to my developers to fix. Here's the average time it took them to fix it. That's my speed. And that brings me to my summary at the end here. I'll just recap all the items. I'm amazingly actually landed exactly at 40 minutes, which was my goal. Move beyond detection. Stop just worrying about detecting new issues and start, because a lot of our tools are now good enough to detect all of the bad issues. Start focusing on things like prioritization. Prioritize those issues with a solid prioritization strategy. Don't stop development. Enable them, educate them, reduce those interrupts. Automate everything you can. Dependency updates, fix suggestions, issue creation. I still see too many people manually creating security issues in Jira. There's a million ways to hook every tool into Jira. Automate everything. But anything you automate, measure, because you want the credit. You not only want the credit, it'll help you actually achieve your goals. So measure the things that actually matter to risk reduction and speed. So I will stop sharing now. That is the end of the presentation. I do want to answer some questions here, and I see one. So let me hit stop sharing here. Any others, please throw them in. Somebody did ask if this was going to be shared afterwards. Yes. I think there's a recording going out as well, Cody. Is that correct?
That's right.
It's good. I was very careful not to swear or anything else that would show up on a recording. I like this one. How do you know which known exploits have been weaponized? There's several services. It's also integrated into most modern SCA security tools. And to be honest, it's actually somewhat relatively common information, which ones have been weaponized. There's several services. We can maybe follow up on them. I'm not good enough to remember them all off the top of my head. How do you know the actual risk of an application holistically? Ooh, this is fun. So I could do a whole nother webinar on things like risk scoring and how to actually put meaningful measurements on it. The problem is most people are starting from an immature point of detection. And that immature point of detection means that the historical data isn't always great. So I tend to focus when I give advice to people on going forward. It's important to measure, but don't worry about what you did last year. Your measurement changed. Throw it out. Measuring your application, your actual risk of an application holistically is a huge topic, but I'll give you some ideas on that. One, if you're prioritizing correctly and only bringing in the ones that actually matter, if you're doing that, the actual CVSS scores of the prioritized issues is not a bad starting point for measuring your open source security risk. It's a number, literally add the CVSS scores up, but only of the prioritized issues. For SAST results, your proprietary code, that also has scoring. Every SAST tool scores those, at least on a severity level, which you could easily assign to 1 through 5. That's a little bit fuzzier because SAST tends to have more false positives than the very good accuracy rate for SCA tools. Because sometimes, to use my stupid analogy from earlier, the word is just uncommon. It's not misspelled. However, you can still measure that. Take the severities, pop them on a 1 to 5 scale, take 2 seconds, and actually just run the numbers. Those are two really good starting points for measuring risk with actual data and numbers. And as I joked earlier, businesses like numbers. If somebody just tells me, well, our application is less risky, I'm going to ask, what do you mean? So more numbers you have, one, the more you can prove your efforts and the value of what you do. And then the more honestly, it's easier to measure. Any studies from your experience on how much risk exposure was because of dead code which wasn't depreciated or deprecated, rather? Ooh, that is a really good question. I have read a couple. Um, Out-of-date libraries specifically is a huge avenue of risk, especially ones that have been end-of-life. Legacy code bases are rife with this. I it's what's in my head is something like 80%, but honestly, 80 and 20% happen a lot in the security industry for some reason. But the older the code base, the more this is an issue. The big issue on this is actually the business value of remediating them. There's a reason people tend to not focus on legacy code bases. However, I'll call back to dependency updates. That is a really good way to at least begin to fix a lot of that stuff. Don't worry about measuring it. Just try to update everything you can and then measure the amount of issues there. In general, most dependency updates won't introduce significant functional risk. And it's pretty easy to test it if it does, especially if you have automated quality testing. And I'm just going to flip over the chat. Nope, same question over there. Good job putting it in the QA too. Thank you, participant number 8. If it's dead code, it's not reachable. I interpreted dead code to be out of date or end of life code, things where they stopped doing security updates, for example. Completely non-reachable code isn't going to introduce any actual security risk almost ever because your application isn't really touching it. There's exceptions in there for things like operating systems. All right. Do you see anything else, Cody? Am I missing anything?
I'm not seeing any more questions at this moment, so I'm going to go ahead and fill this little bit of dead air with some gift cards. Does that sound good?
Only if I'm eligible. Am I eligible?
Well, we'll just have to let the random drawing decide. So these are for 4 $25 Amazon gift cards. Our first winner is Elizabeth P. Our second winner is Dakota V. Our third winner is Jason E. And our fourth and final winner is Rainier V. So to the 4 of you, congratulations. Please keep an eye on your inbox to claim that gift card. But if you don't happen to see that email, please check your spam folder. I'll also take this opportunity to remind everyone that this session was recorded. So following this webinar, you should be receiving an email with a link to access that recording on demand. You can also find it living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. All right, Jeff, did we get any more questions in that amount of time?
I didn't see any, and I always like to give people some time back. So I'm pumped. We hit the 50-minute mark almost exactly. That's great. Everybody gets 10 minutes back to their day.
Awesome. Well, Jeff, is there anything that you would like to leave our audience with? Any parting words before we close out?
Covered most of it in my summary, but the big one is measure, automate, and prioritize things. Should have put them in the other order. Prioritize, automate, and measure.
Great. Well, Jeff, thank you so much for taking the time to join us and running us through everything. It was super helpful. And I can see with all the questions and activity we had going on that our audience really did enjoy this. So thank you so much.
No problem. And thank you, Cody. And thanks to the audience. You guys are great.
Yes, I'd like to thank Mind, our sponsor for today's webinar. And I'd also like to thank you, our audience. We really appreciate you spending time with us. We ask for one extra moment of your time to fill out a brief post-webinar survey, but otherwise, we do hope to see you at an upcoming Techstrong Learning workshop or webinar. Everyone, have a great rest of your day.